Today we're going to continue with the basics of geometry, and we're focusing on segments and their measures. Postulates or axioms. These are rules that are accepted without proof. Your first vocabulary word. Another vocabulary word for today, theorems. Theorems are rules that are proven. So in geometry, we're going to be talking about postulates and theorems. So our first postulate, our first idea that is accepted without proof is the ruler postulate. This says that the distance between points A and B, and here we have an illustration, is the absolute value of the difference of their coordinates. Alright, so for instance, if we want to know the length of AB, and we just write AB if we want to know its length, it's the absolute value of the distance between the coordinates. So to get from A to B, A is at 0.5, B is at 8. So we take the absolute value of 5 minus 8, which is the absolute value of negative 3. So the length of AB is 3. Okay, and I think you can see that. To go from 5 to 8, you have to move 3. Distance is always positive. That's why we can use absolute values for distance. Going on to the next page. Postulate 2 is the segment addition postulate, which basically says if B is between A and C, then AB plus BC equals AC. So just kind of trying to write that again like what we just had. We had A in our last picture, B and C. I'll just do that much. We knew that A was at 5, B was at 8, and C was at 10 on the number line. And so if B is between A and C, then the lengths of AB plus the length of BC equals the length of AC. Well, the length of AB from 5 to 8 is 3. The length of BC, which is from 8 to 10, is 2. Which gives us the length from A to C. Well, we know that from A to C, from 5 to 10, should be 5, and sure enough, 3 plus 2 does give us 5. All right. Next, distance formula. This is something, it looks a little more complicated. It's really not. It says if you want to know the length of AB, or length of any segment, really, it's equal to x2, the square root, I should say, of x2 minus x1 squared, plus y2 minus y1 squared, where x1, y1 and x2, y2 are the endpoints of segment AB. So for instance, let's say that we draw these segments. We're just going to sketch them. They're not going to be to scale or anything else. Let's say that we have these points A, B, C, and D. So we just put them here. We're not worried about drawing to scale, having them necessarily in the right place. So here's A, B, C, and D. We're going to connect them, and we're going to create any segments that these could possibly make. Look at this. We can even connect B and D and A and C. So these are all possible segments. Here are the coordinates of those segments: negative 1, comma 1, negative 4, comma 3, 3, comma 2, and 2, comma negative 1. Now, we would like to find the lengths of all those segments. Well, we'll do a few, and then I'm going to have you try some. So then we want to also know, are the lengths of any of the segments equal? So for instance, segment AB. Now we're using our formula. I'm going to rewrite it here. Actually, let me just change the spot of that a little bit. Let me put it right below our figure. So we're going to have x2 minus x1 squared plus y2 minus y1 squared, just like this. Okay, so if we want to find the length of AB, now AB uses the points -1, 1, and -4, 3. Those are the points A and B. So let's label them. First point is x1, y1. I bet you remember this from algebra. Second point, x2, y2. The labeling the points. Alright, so now let's plug those numbers into our formula. So x2 is -4 minus x1, which is -1. And we're going to have to square it. Plus y2, which is 3, minus y1, which is 1. Square it. Well, these two negatives make a positive, so this is the same thing as having -4 plus 1, which is -3 squared, plus 3 minus 1, which is 2 squared. Let's actually do this now. -3 squared is 9. 2 squared is 4. So we have square root of 9 plus 4, so we get the square root of 13. And if you do want to change that to a decimal, it's fine. You can, it's perfectly acceptable to leave it as the square root of 13. If you do change it to a decimal, it is approximately 3.6. Okay, so that's the length of segment AB. All right, now let's try the length of another segment. Let's do BC. So BC has the points -4, 3, and 3, 2. So let's write that down. All right, let's plug those into our formula. X2 minus x1 squared plus y2 minus y1 squared. So let's label our points for BC. So we have x1, y1, x2, y2, and we'll plug our numbers in to the distance formula. So we have 3 minus -4 squared plus 2 minus 3 squared, because y1 is 3 and y2 is 2. Well, 3 minus -4 gives us +7, because our two negatives become positive, so I have 7 squared, plus 2 minus 3 is -1. We'll square that. So we have the square root of 49 plus 1. So that gives us the square root of 50. If you do want to write the square root of 50 as a decimal, that's fine. It is approximately 7.07. If you want to just leave it as a square root of 50, that's perfectly okay. Now, I'm going to leave it to you to find the length of the other segments. I think what we're going to do is we're going to start doing that in class. So when you come back to class, we're going to find the length of the other segments in this problem and figure out which ones are equal. So that will be the first thing we do when we come back to class. Let's move on to the next page in our outline. The definition of the word congruent. Two objects that are equal in size and shape, in other words, two segments that have an equal length, are congruent. Now, if we had this situation here, AB equals AD, that means those two are equal. But what's also true is that AB would have to be congruent to AD. In other words, segment AB would have to be congruent to segment AD. We can put the word segment right here. The first statement just says that the length of AB is equal to the length of AD. Those two are also segments of the same segments over here. But equality also implies congruence. So for example, let's say that you have this situation. B is between A and C, R is between A and B, and S is between B and C. AR is equal to RB, which is equal to SC. AB is 6 and AC is 17. Find RC and SB. And you might be thinking, oh my goodness, how am I ever going to do that? Well, it's really not that bad. What we need to do is draw a picture of what's going on here. Now, to start off with, it says that B is between A and C. So if I have to make this longer, so be it. But I'm going to start with A here. Here is C. Now, since we're making a sketch, this may or may not end up being drawn to scale. It probably won't be. But we know that B is somewhere in between them. So I'm going to put B right here. Now, I know that R is between A and B. So I'm going to put R right here. I may or may not have it in the right spot. But it is somewhere in between them. S is between B and C. So I know S goes somewhere over here. Now, let's see. AR, RB, and SC, it says, are all the same length. So I'm going to make this little mark to show that these are equal. AR is equal to RB, which is equal to SC. Okay? You've probably seen those marks before. If you haven't, that just means that those segments are equal to each other. Now, AB, we're told, is 6. So from A to B, it's 6. From A to C, it's 17. Find RC and SB. Well, let's think about it. If from A to B, it's 6, and we know that A to R and R to B are the same length, AR and RB each have to be 3. We know AR, RB, and SC are the same length, so SC has to be 3. Now, so right now, we need to find RC and SB. Well, we can certainly find SB because we know that from A to C is 17. And so far, we've got 3, 3, and 3. So we know that we have a total of 9, and we just need to find what's left over, which will give us SB. So 17 minus 9 gives us 8. So there's our length here. So we know that SB is 8. And therefore, from R to C, we have 3, 8, and 3. So 3 plus 8 plus 3 gives us 14. So the length of RC is 14. So see, it's really not bad. As long as you draw a picture, you've got something to go from. And if it's not drawing to scale, don't worry about it. We just need to get a picture down to help us do the problem. Thank you for joining me.